Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and in this video we're talking about the probability of more than one event. So let's start with things we should know. So previously on Hegarty Maths, here is a question for you, a type of single event probability we've done. Pause the video and check you can do it. Well, it's very simple. The probability of getting a 3 here, which we write as that, there is one possible 3 out of a total of 5 possible equally likely outcomes because we have a fair spinner, so that's our probability. Next, what's the probability of getting ahead here? Well, that's quite easy. The probability of getting ahead, there is one head out of 2 possible outcomes, heads or tails. So nice and simple. Now what we're doing in this video is something like this. Imagine Colin not separately spun a spinner and then flipped a coin. He did them both at the same time. So Colin spins a fair spinner as shown, and he also flips a fair coin at the same time. What's the probability of getting a 3 and a head? So pause the video if you think you can already do this question. Right, so this is a simple case of considering the two single events in a combined setting. And what we would do for this, there's a nice little idea that will help us get these nice and easy. It's drawing what we call a sample space diagram. So let's say along the top, let's consider the sample space for the dice. What outcomes can you get? Well, you could get a 1, a 2, a 3, a 4, or a 5. Okay, and let's go down the page to say what we would get for the coin. So for the coin, what possible outcomes can we get? We can get a head or a tail, right? So if we were to populate this, it's kind of like a table if you think about it. If you could do it like a table like this. So in the first case here, we get a head, and get a head with a 1, get a head with a 2, get a head with a 3, get a head with a 4, get a head with a 5. And in this case here we get a tail with a 1, tail with a 2, tail with a 3, tail with a 4, and tail with a 5. Now this picture is really helpful for us. It tells us all the number of possible outcomes you can get. We can get, if we count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 possible outcomes, and they're all equally likely because heads or tails were equally likely, and each of the 1, 2, 3, 4, 5 were equally likely. So there are 10 outcomes, and we were asked what is the probability of getting a 3 and a head. So we look down here, where do we have a 3 and a head? Only in one case here. So there is one possible outcome out of a total of 10 equally likely. So the probability of a 3 and a head is simply 1 out of 10, like that. Okay? Now I do want you to notice something we'll come back to later. Do notice that the probability of a 3 in itself, as we said previously, if we go back here, was 1 out of 5, and the probability of a head was 1 out of 2. And it so happens in this case that 1/5 times 1/2 would have given me the 1/10 as well. And we'll look at ways of doing the questions quicker like that in future. But for now, the sample space is really helpful, and in particular these scenarios can get a little bit more complicated, and it's really helpful for us. Right, next one. Pause the video and have a go at this one. So Colin flips 2 fair coins at the same time. What's the probability of getting all of the following? Now the easiest way to do this is to do the sample space diagram. So for coin 1 we can get a head or a tail, let's say, and for coin 2 we can obviously get a head or a tail. We're told they're 2 fair coins. So let's populate this sample space diagram here. So what are the options? Well, we either get a head and a head, we get a head and a tail, we get a tail and a head, or we get a tail and a tail. Now clearly there are 4 possible outcomes there. So what's the probability he gets 2 heads? Well, there is only one such scenario of that, one such outcome like that, so the probability of 2 heads, there's one possible out of 4 possible outcomes, so it's a quarter. What's the probability of 2 tails? Well, again, there is only one outcome where there are 2 tails, so it is 1 out of 4 again. Okay, now what's the probability of the same result on each coin? Now this is where the sample space diagram comes in really neatly for us. The same result on each coin. Well, in the case of a head-head, that's the same result on each coin. In the case of a tail-tail, that's the same result on each coin. So you've got 2 out of a possible 4 outcomes. Alright, so the answer here is 2 out of 4, and that obviously simplifies to a half. And the last one, a different result on each coin. Well, here the 2 coins are different, here the 2 coins are different, so clearly it's going to be 2 out of 4 again, which is a half. So the probability that they're different again will be a half. And the sample space diagram was the easiest way to see these type of things. Right, next question. Pause the video, have a go at this one. Okay, this is the same sort of question, so you start by drawing the sample space diagram for each of the dice. And that's our sample space diagram, and it's really helpful for us because it shows us there are 36 possible equally likely outcomes, 6 times 6, and we can read off any information we need from that to answer questions. So it asks us, what is the probability of getting 2 6s? So all we need to do is look at our sample space diagram and see where 2 6s occur. 2 6s only occur one place out of a total of 36 equally likely outcomes, so it's 1 out of 36. What's the probability that both dice show the same number? So same, I'm just going to put the probability that they're the same. Well, that happens in numerous cases. That happens when they both show 1, they both show 2, they both show 3, 4, 5, or 6. So there are 6 out of a possible of 36 outcomes. And that simplifies dividing the top and bottom by 6 to 1/6 as follows. And then it says, what's the probability of 2 odd numbers? So let's just write 2 odds. So we might have to count this a little bit more carefully. Let's just think about 2 odd numbers. Well, they're both odd numbers. They're both odd numbers. They're both odd numbers. Let's look along each list here. So they're both odd numbers. They're both odd. Here, they can't both be odd here when there's a 2 involved. They can't both be odd. Here, they're both odd. They're both. They're both. Here, they can't both be odd with a 4, but they can in the case of 5. They're both odd. They're both odd, and they're both odd, and they can't be in the case of 6. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So the answer is going to be 9 out of a possible of 36. And again, we can simplify the answer, divide top and bottom by 9, and we get the answer 1/4, and we're done. Right, next question. Pause the video, have a go at this. Okay, same stuff here, but this time he rolls a fair dice and flips a fair coin at the same time. So you draw your sample space. And that's our sample space there, and it shows us that there are 12 equally likely outcomes. So the probability of a tail and a 3, probability of tail and 3, we just look here, there's only one of those out of a possible of 12, so it's simply a 12th. And then the probability of a head and a number more than 4. So probability of head and more than 4. Let's just count those up from our sample space diagram. You've got to have a head, so it's got to be in this line here. More than 4, there's one of the numbers more than 4, 2 of the numbers. So it's going to be equal to 2 out of 12. Dividing top and bottom by 2, that simplifies to a 6. And that's it for this particular video. Thanks loads for watching.